we learn about the chapter variation and heredity. What is variation? When two organisms or more than two organisms different from individual features of them, then the different of these features which can show the individualities is called the variation. What is the causes of variations? There are so many causes for the variations. One, when the crossing over takes place in meiosis cell divisions. Crossing over is the one important cause of variations. Two, mutation. When the mutation takes place in the germ cells or the zygote of the formation of organisms, then the variation is takes place. And three, the haphazardly combinations of chromosomal structure. The chromosomal structure when combined is haphazardly at the formation of zygote. The chromosomal combination form at the formation of zygote. Now we learn about the causes of variations. Now here I represent what is the type of variations. How many types of variation? That is two types of variations. One, somatic variations, and two, another is germinal variations. Somatic variations and germinal variations. What is somatic variations? When the variations take place only the somatic cells, then this type of variation is called the somatic variations. It is followed by the Lamarck's theories. Somatic variations evolved by the follows of Lamarck's theories, and germinal variations is the variations which take place by the gene change or genetic change. That is two types, the continuous and discontinuous. Now we learn about the somatic variations. It is one, somatic variations takes place by the environmental influences. Environmental influence. When environmental influence affect on our somatic cells, then this type of variation can be formed. Examples, so many examples I have here. That is lack of example, when the lack of light, that is sunlight, presents in any habitat of plant bodies, those plant bodies whose take the lack of light shows the longer internodal stems. Lack of light causes the longer that is node, that is node, that is node, that is internode. Internodes means the zone in between two nodes of stems. When it get the lack of light, it insufficient of light shows the longer internode. Next, other examples is the larva of bee larva, when get the pollen bead, the pollen bead taker larva converted into the worker bees. But the royal jelly taker larva formatted into queen bees. So it is the another examples of the environmental influence, how the environment can affect on the somatic variations. I repeat here. Another, the high sunlight zone and high temperature zone of Earth produces the more or less the black human skin, because the melanin excretion is highly and the skin is so dark. That is the tropical area, here the tropical zone. All over the year the sunlight thrown into these areas, it is vertically, and after 10 degree north and 10 degree south, this zones is called the tropical zone, and maximum habitat yet the human beings is so dark, that is Negro found in Africa, Congo. Residents are so many dark humans. All are the examples of somatic variations, that is caused by the environmental influence. Now, the second issues of Lamarck is the second component of Lamarck theory is the use and disuse. When the organs of any organisms can used maximum, this organism is strongly exposed in environment, and those organs are not used sufficiently is shows their capability or functions as the weak part of the body. Now, we all the right-hander, those humans right hands, cricket ball throw in right hands, painting in right hands, all of the work, maximum work loaded over on the right hands, but left hand is comparatively weak than the right hands. It is the use and disuse hypothesis by the Lamarck. It is for these causes the somatic variation can take place. And the three is the conscious efforts. Conscious efforts. What is conscious efforts? Consciously, when we behave or use the organs of our particular sense, then we can develop these type of organs of those particular senses of particular functions. That is, this type of conscious efforts cannot flows in hereditary way. The use, disuse, and the effect environmental influence also flows by the heredity, but the conscious efforts which can enhance by the organisms cannot flow the heredity or genetic sequence, because it is not flow by the hereditary, because any human can make a mud pot carefully, and it is the so skillful appearance of these humans, but those humans cannot produce the same skillful sounds that this type of human can work as the marpot. Clear the marpot. Now, three types of effects that can cause of somatic variations I represent here. Now, the germinal variations. What is germinal variations? Germinal variations is not only the somatic cell oriented, it is oriented only the germinal cells where the chromosomal or genetic functions is exposed and is so strong. That is, two types of germinal variations are continuous and discontinuous. Continuous and discontinuous germinal variations. Continuous germinal variations also follows the total roots of Charles Darwin's hypothesis, that is natural selection theories. All the natural selection theories can be followed by this type of continuous variations. These two types. One, substantive, another is meristematic. Substantive and meristematic. What is substantive? Continuous variations. That is, the color of humans. So many humans we see all of the days, months, years. The color is vary from one man to another, vary one to each other, one to others. And the hair style, hair color are so many different. That is the substantive continuous variations. Mathematics is the number oriented. That is the how many eggs can lay by the duck or hen. Now this is the mathematic continuous. That is the 5 fingers in each hands of humans. The 6 finger found in the Hrithik oceans. Mathematic continuous germinations. Discontinuous germinal variations is two types. One, that is mutation oriented and chromosomal structure oriented. What is mutation oriented? Mutation oriented, the suddenly huge change of protoplasm and the germinal cells. This variation can take place in this type of changed protoplasmic or germinal cells. That is gene mutation or point mutation. Gene mutation or point mutations. Chromosomal structures are divided by the various processes, that is deletion, duplication, inversion, translocation, aneuploidy and euploidy and polyploidy. All of the causes can take place in this type of discontinuous variations. Now we learn about the heredity. Heredity is the term, and it is so involved by the scientist. It is so involved by the scientist Gregor Johann Mendel. Gregor Johann Mendel. Gregor Johann Mendel is the father of genetics, and the gene is the term which coined by the scientist Johansen. In 1909. What is heredity? Heredity is the process by which the total features is carried out from the filial generation to the daughter generation. The filial generations to daughter generations by which the features of the filial generation is carried out into the total generations is named as the heredity. For the knowledge of heredity, some terms are so useful or necessary to know. What is this? That is gene, that is allele, and that is phenotype, and genotype. Gene, allele, phenotype, genotype, homozygote and homozygous, and heterozygote, and heterozygous. Hybrid. Next, now we learn about this type of term. What is gene? Gene is the nucleotide materials found in either DNA or RNA, that is ribonucleotide, ribonucleic acids, which is located in the chromosomal structure of eukaryotic cells and the nuclear structure of prokaryotic cells, which is the determinant of the whole features of the organisms. It's called gene. What is allele? We learn about allele for the point of locus. What is locus? It is chromosome. That is the point where the similar or dissimilar genes are found. The certain places of chromosome where the genes are, the intensity of genes are more, or the genes are found. This point is called locus, and the certain locus where the similar and dissimilar genes or the pair of genes are found is called allele. Allele. So allele is those type of genes are found in the certain locus, that is similar or dissimilar. Phenotype and genotype. The external features of any organism is called phenotype, and those external features or phenotype is exposed for those type of genetic combination is called a genotype. So it is the cause and it is the effect. Now homozygote and heterozygote. Homozygote and homozygous, heterozygote and heterozygous. Now I discuss it. That is the capital T, the pure long pea plants, and that is pure short pea plants. It produce the gamete, that is one, that is male gamete. It produced the gamete, that is female gamete, and after the meeting of the gamete for the process of fertilizations, that is produced the zygote, that is the separate gene structure. Mendel said this type of structure. For the Mendel language, this is the factor, not gene. This time Mendel cannot know about gene. He said it is the factor which is the determinant of the features of the organisms. The separate factor, separate gene when form a zygote, it is called heterozygote. The separate zygote which form the separate gene which form a zygote is called the heterozygote, and the organisms is called the heterozygous. That is heterozygote and heterozygous. And we see here the plant is so tall, that is these features can carry into the filial generations, that is the P generation, that is the first filial generation. So here we discuss the two type of term, another term, that is the dominant and recessive. What is dominant? After crossing of two pure opposite features gametes, in the first generations, the one feature is exposed, phenotypically the one feature is exposed and another is the not exposed. It is found but not exposed. It is called the recessive. That is the short features is recessive here and the tall features is the dominant here. So when the crossing of two pure breed, the first filial generations where those features is not exposed is called recessive and those features is exposed is called dominant. Now we learn about the homozygote and homozygous. That is same plant, same features when meeting for their same gamete and produced the same zygote of pure breed and produced this type of plants of first generations. This is called the zygote is called homozygote and this plant is called homozygous. Now we learn about the preliminary steps and terms of heredity